Okay, so hi everyone, welcome to my YouTube channel, City of Elections, and in this video we are going to talk about this example using all the ideas we've learned in the previous thing. So I just opened this in side by side, the documents, and that's our PDF, and then where we used to do the follow-up solving here alongside. So it's just the same. It's just the same thing. Find the z transform of the signal. This exactly the same thing what we have here. I just copied it and brought it here. So I'll be doing my like side by side solving. Not everything, but come on, guys, you understand. And just to explain further, I will solve here. Okay. So now we are asked to find the z transform of this signal. Guys, bear in mind that, let me write it out first. So bear in mind that 1 over n u of n, right? They will now have x of n equals this. Now looking at this guy, just this part is the signal. Okay, this part is our discrete signal, and we say it's a discrete signal because what we have here is what? N, not t. If we have x of t, then it's a continuous time signal, but since it's x of n, it's what? Discrete time signal. So what we do is this is the signal, right? This part is the signal. Now what about this other part? I've already explained this other part in the previous video when I said this one. Now you go from where? You go from 0. N will start from where? 0, because yes, n will start from 0. Oh, I did something in that video which I wasn't supposed to do, and let me just expand and make that in clear here. Now let's look at it here. So it is what? N equal to or greater than 0. So you get, so when n is equal to 0 or greater than 0, look at it, n is equal to 0, here is 1. So when n is equal to 0 and greater than 0, exactly, that's where we have values of x of n. So in our own case here now, this thing just means that n will start from what? 0 to what? To what? Infinity. That's the meaning of this. Again, this part just means that n will start from 0 to what? Infinity. Not from negative infinity to infinity, but from what? 0 to infinity. Exactly. So that's the meaning of that part. So let's go back to the solving now. So since we've understood what that thing means, what's happening next? Now, first thing first is to write out the formula. So we write out the formula saying, since we are looking for x of z, we are asked to find the z transform of this, right? The z transform of x of n is what? X of z. Look at it, x of z. Now this question is, if you think of it, this question is actually simple because we are not asked to analyze the signal and identify the properties, identify the stability. We are not asked to even do all that. We are just asked to find the z transform, meaning apply the mathematical tool z transform on it. So the z transform, which is x of z, will be what? Just write out the formula first. Okay, from negative infinity, we have not applied anything yet. We have not applied u of n or anything. We are just writing out the formula first. So and here will be what? X of n multiplied by z raised to power minus n. This is just the formula. We've not done anything. Now this is what we have here, exactly what we have here. So what happens next is this. After writing this, x of z equals all this, what happens next is that where you have x of n, are you seeing it? Where you have x of n, you now put in what? You now put in, look at it, you put in what? This guy. Are we seeing it? So look at it. X of n is this. X of n. So where you have x of n, instead of writing x of n, you write this thing. So that's what they have exactly here now. Are we seeing what's happening? Okay, that's the substitution. This thing, look at positive infinity, n equals to negative infinity. Now, this guy will now come in, u of n, so we'll now have what? N equal to 0. Are we seeing the effect now? This one will just use the formula. The next step will now apply what u of n means. So here will become what? N equals to 0 to infinity. And then this place now will now be what? 1 over 2 raised power n, because of x of n means 1 over 2 raised power n. This z just remain there. Okay, I believe that's clear. Now, the next step, how they moved from here to here, I will show us right here now. So what's happening here is this. If you look at 1 over 2 raised power n and then z raised power minus n, just only these ones like this. Now, look carefully, guys. Look carefully. You have n here. You also have n here. So meaning we can what? Factor out n. So what you now have left to be what? It will be 1 over 2. Of course, if you remove n from this, what will be left is just 1. And writing 1 doesn't really mean, so you can leave it out. You can leave it out. Then what you now have here is what? Z. When you remove n from this, what will be left is what? Minus 1. And because it's negative 1, you should have it there. For this other guy, after removing n, we have 1. No need to write it. For this other guy, after removing n, we have minus 1. There is need to write it. Okay? Minus 1. So the n will be what? Outside. The n will be outside. Of course, you can multiply it back, saying, you can say this thing. If you want to return it back, you can say this times this will give you what? 0 raised power what? Minus n. This times this will give you what? 1 over 2 raised power n. Exactly the same thing. Okay, so where you have it like 1 over 2, look at it, 1 over 2 multiplied by 0 raised power minus n. Look at it, all raised power n, all raised power n. It's exactly the same as this. Exactly. So from here to here, I hope that's clear. Leave it in the comment section if you have any question. So after that has been done, since we now have an expression from n going from 0 to what? Infinity. Now we can say when n is equal to what? Starting from 0, 0, 1, 2, and so on. This is the first term. This is the second term. This is the third term, and so on. So look at this now. Yes, this is what they have here. When n is 0, when n is 1, when n is 2, and so on. What they're actually asking you to do is that take the formula, or take your expression now, which is, let me just write it again, which is this one. Let me write it out here. So take that expression, which is this one, and say when n is what? 0 for the first term. So first term will be what? The first term for x of z. So we now have what? 1 over 2 z minus 1. When n is what? 0. So here will be what? It's supposed to be n, but when n is what? 0. Anything raised to power 0 is equal to what? 1. So everything here will be equal to what? Sorry. Will be equal to 1. That is why you see what you have here. The first term is what? 1. Exactly 1. Now, for the second term, so for the second term, n is what? N is 2. So you bring that one here. Meaning here will now be what? Here will be what? 2. Okay. Here will be, what did I just say? The second term, n is what? 1. So here will be 1. Guys, So here will be 1. In the first term, n is 0. Second term, n is 1. So here will be what? 1. So that's what you have here. And anything raised to power 1, that thing will remain the same. So we just have exactly the same thing. Exactly the same thing. So that is why we have our second term as this. Now, what about our third term? For the third term, n is what? 2. Meaning here will be what? 2, because this is where n is now. Remember, we are looking at this formula. Okay? So n is 2. Meaning, we'll now have everything raised to power 2. Look at it. Everything raised to power 2. For the fourth term, n is what? 3. So fourth term, here will be what? Here will be what? 3. And so on, and so on, and so on. Okay? So you can see that that's how we have it until first term, second term, third term, and that's how we have it until the nth term. Okay? Now, call this one equation 1. Call this line what? Let me make that bigger. Alright. So call this complete line what? Equation 1. This series. Now, what we are looking for is x of z. Okay? So we need a definite term, not a series. So to remove the series, we'll now multiply everything by what? What you have here. You multiply by what you have here. This is the same thing as this. It is the same thing as this. It is the same thing as this. Are we seeing it? Since this term repeats in all of them, here it is raised to power 0, so it's just 1. So it is that term we are going to use to multiply both sides of equation 1. Is that clear? So 1 over 2, z raised to power minus 1. Use this thing to multiply this side. You have what? Look at your x of z. Look at it here, x of z. 1 over this term, look at it here. So that's how they are multiplying themselves. Okay? That's how they are multiplying themselves. Now, with that being said, what's going to happen now? So we have used this to multiply this. Is that not so? Now, use the same thing. Sorry, when we use this to multiply this, we got this part. Is that not so? Now, use this to multiply this first term. You now have what? You have what? Oh, they placed it outside first. Okay. Now, look at what they did in this book now. They first wrote everything. Look at all these things. All these things, All these things. Look at them here. Look at them here. Are you seeing it's the same? That's what you have there. Then this term now, this one we're using to multiply. Look at it outside here. I believe that's clear. And also look at it here. So this has multiplied this left hand side to give you this one. For the right hand side, everything here, look at it. This one, look at it. I believe you are following. So what happens next? We've already multiplied this guy, so that's it there. Clear. Now, this will multiply. Let me take it step by step. This will come and multiply this. Okay, and it will give you what? This. Exactly. Then I think I should use a different color for it. A different color for it. So this will come and multiply this to give you this. Exactly. Then for another one, this will also come and multiply this to give you this. Are we following? Now, this term is exactly the same as this term. Is that not so? Remember indices where you say a times a is equal to what? A square. Because the two terms are the same. Let me break it down a bit. The two terms are the same. You pick one, then you now add their powers. You add their powers. Of course, in raised to power invisible 1, raised to power invisible 1. Those invisible 1 add yourself, you now get what? A raised to power 2. So that's what's going on. That's what's going on here. So this term is the same as this term. So therefore, the answer will be what? When this multiply this, the answer will be what? This term raised to power what? 2. Similarly, this term times this term will be what? This same term raised to power what? 3, and so on. Now, for the last term we have here, you see that this term raised to power n, you have it here. This term raised to power invisible 1. Let me just use a different color and write that. So you see you have this coming to multiply this. So that's why you have everything here. Okay. So just like indices now, like we said, since this inside is the same as this one, you pick one and then you add their powers. This is used by invisible 1 now. So n plus 1. That's why we have it. That's why we have that there. Okay. So I hope that's clear. Now with this we now have equation 2. So we have equation 1 and we have what? Equation 2. Now we've not still gotten x of z. So from equation 1, if you look at equation 1 carefully, guys, look at equation 1 carefully. Everything you have here, let me mark that thing. Everything you have, I need a color, I use red. So everything you have from this part, forget about the one first, from this part to this part, it is the same. It is the same with what you have in equation 2 from this part. Okay, are we seeing it? This guy, sorry, I cancelled the 2 by mistake, but the 2 should be there. The 2 is there. This guy is the same with this guy. So if you remove this one, bring it to the left hand side, that means all this side now, we can now work with it. Look at it. From equation 1, you bring this one, look at it, this one, bring it to this side, so you have x of z minus 1. Look at it, x of z minus 1. Then the restings, look at the restings, look at them. That's what you have here. Okay, that's what you have here, the restings. So you can put this whole expression, say put this equation, put this into equation 2. Now look at equation 2. Okay, so this is equation 2, Abby. This, look at it, this equal to what? X of z minus, correct, that's correct, that's correct. So meaning that x of z minus 1 equal to everything here, Abby. And for equation 2, meaning in equation 2, all these things you have here, everything here is now what? The same thing as what? This guy. Because this guy is equal to what? This guy. So instead of writing this whole long thing, this whole stuff, just write x of z minus 1. Is that clear? So, and of course this other part will remain. Oh, this plus sign is out. That plus sign should be at this other side. So don't worry about that. Just know that instead of writing all this, because all this is the same as this, which is the same as this, we can now say everything here, change all these things here to what? Let me use a different color so you see what I'm saying. Change everything there to what? X of z. I should use a different color. Change everything there to what? X of z minus 1, then plus this one. That's what's going on here. So this whole thing, look at it here, is equal to what? X of z minus 1 plus what we have here. Pause this video, look at this thing, and be sure you understand it. Leave comment in the comment section and let me know if you have any question. Now, at this point, now we are almost done. At this point, we are almost done. At this point, okay. Now, like what our lecturer said in class, you don't really need to divide through by 1, but since we want all the x of z to be at one side, if we bring x of z to this other side, x of z will have a minus sign. X of z will have a minus sign. And we don't want what we are looking for. We want it to be without a minus sign. We don't want it to have a minus sign. We want what we are looking for to be positive. So therefore, bringing it this way will make it to become minus, abi? So just divide through by minus now at this step, so that by the time you move it to the other side, it will have a plus sign. Look at what we mean. So when you divide through by minus, here will become, here was plus. When you divide by minus, it becomes minus. Look at it. Here was plus, invisible plus. When you divide by minus, it becomes minus. Look at it. Here was minus. When you divide by minus, it becomes what? Plus. And here was plus. When you divide by minus, it becomes minus. The rest things, the rest expression are the same. It's just the signs that changed. And I explained to you why the signs had to change, because we are dividing by 1. And we divided by 1 because we want our answer to be positive. So now, when you move x of z, when you move it to this other side, look at it now. X of z. Look at x of z now. It's now in this other side. When you move it here now, this minus now becomes plus. If we had not divided with this minus, by the time we move it, it will now show you minus, which is what we don't want. So that's why we divided by minus first before moving it to this other side. Of course, this other guy is minus. This one is the one we moved just now. Minus becomes what? Plus. This other minus, x of z, and these guys, they remain there. They remain there. I hope we are following. So, yeah. This guy brought to this side. This one remain here. Then 1, 1, minus, minus, all this, all this. Perfect. Perfect. We're almost done. So, now all we have to do is this. Since you have x of z here, you also have x of z here. Factor out x of z. Meaning, when you factor out x of z, what will be left is just 1. X of z is now outside. Of course, also factor out x of z from here. This guy will be what? Left. So that's why we now have 1 minus these other guys here. Let me erase that. Okay? Hope that's clear. Now, this other part just remain the same right here. And then, of course, divide both sides by all this thing. So, this guy now, this one will come under to stand under here, which is what you have right here. Okay? And then x of z is now separate, and you now have all this one as a 10. Let me erase that. Okay? So, after that is done, then we'll now consider, we have x of z equals to all this now. Consider this. If this expression, which is what you have under, is less than 1, that is 1 over 2 z of minus 1 is less than 1. Our lecturer said something that we should, in this part, we are just looking at, forget about this one. Okay? He said we are just looking at this. Okay? That if this is less than 1, okay, that means, let's say, less than 1 means 0.9 or 0.8 or 0.7 or something like that. If this is less than 1, okay, then this expression, raised to the power n plus 1, will be 0. Because this thing, raised to the power, let's say, even if it's 10, what you have, your answer will be what? 0.0000. Okay, so your answer will just be very, 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 very small, like so small. So what you have to do is what? Then this expression will be what? 0 as n increases to infinity, as n tends to infinity. So therefore, all this one that is having a raised to the power n, you remove it. Okay, you cancel out all these parts. Consider them as what? 0. So you just have 1. You just have what? 1 over these guys. That's what you have here. 1 over these guys. So x of z equals this guy here. Now, so where the region of convergence is 1 over z is less than 1, or x of z is greater than 1 over 2. So this is it. This is our answer. We can stop here. We can stop here. Okay, that's the answer. Now, all right, so for this region of convergence, how come about this value and then this value? Note that we have two values here. We have this, two expressions here, and we also have this expression. Note that we have two expressions here. This is one expression, and then this is another expression. So how come about these two expressions? Remember, we said what? We are considering this term 1 over 2 0 square minus 1, which is what? Oh, I've cancelled this thing. But it is what we had on top of here. Okay, this term here, that particular term is what we considered. Okay, that particular term. So I will say it's what? That thing. Now, if that term is what? Less than 1. So look at it. This thing. This thing. That thing you have there. That's exactly what you have here. Exactly. So you have gotten your region of convergence. That's the first one. But take it outside. Let's take it to this other side. Okay, so take it out to this point here, which is what? 1 over let's zoom in, which is what? 1 over 2 z minus 1 less than what? 1. So if you simplify this, remember z minus 1 is written as 1 over z. Not be so. So 1 over 2 times what? 1 over what? Z. Okay, less than 1. Now, this will be what? 1. This will be 1 over 2. Of course, move this z to this other side. It will be what? Less than z. Okay, just like saying 1 over 2 will be less. So 1 over 2 will be what? Less than z, meaning z is greater than 1 over 2. If 1 over 2 is less than z, that means z. If 1 over 2 is less than z, it means z is greater than 1 over 2. For 1 over 2 to be less than it, 1 over 2 less than z is the same as z greater than 1 over 2, which is what you have here, z greater than 1 over 2. Okay, so that's our region of convergence. All right, so that's it. That's how we got those things. So yeah, thanks for watching. Like, share, subscribe, and I'll see you in the next video. Bye for now.